creo que nos vamos a tener que reunir otra vez por un par de horas. A ver, ¿qué días podría ser disponible? Yo puedo el jueves 1 de marzo, o sea, sería el próximo mes. Pero, bueno, el próximo jueves. ¿Qué le parece a usted a partir de las 11 de la mañana?
The goal of Project Enthusiast is to translate spoken Spanish dialogues into English. Building on resources already developed for Alex Waibel's Janus project, we are concentrating our efforts on the translation of dialogues in which two people are scheduling a meeting with each other. The dialogues are collected by giving participants calendars such as this one and asking them to schedule a 2-hour meeting with each other during a time that is free according to the calendars. The dialogues are recorded and transcribed according to conventions developed for the Janus project. Translation of spoken dialogues involves tackling several problems that are not present in written text. Spoken language is highly disfluent, including many speech errors, false starts, and self-corrections. The machine translation system may also have to deal with imperfect output from the speech recognizer. The following demonstration illustrates translation of written transcriptions of Spanish dialogues. You will hear people speaking, but this is only a simulation. Actual integration of machine translation with speech recognition is scheduled for this year.
¿Qué día podría ser disponible?
What day is good for you?
Podríamos reunirnos a las 8 el lunes 5.
We can meet on Monday the 5th at 8 o'clock.
Pero yo prefiero reunirme más tarde.
But I would like to meet later.
¿Y el martes 6 no va a estar en la ciudad?
And Tuesday the 6th, are you not in town?
No.
No.
¿Qué tal en el hasta qué? Jueves 8 a partir de las 11 de la mañana que tengo libre.
Thursday the 8th from 11 a.m. How about if I am free?
Está muy bien para mí.
That is good for me.
Entonces a las 11 el jueves 8.
Then Thursday the 8th, 11 o'clock.
The input to the machine translation system is a transcribed sentence from the database of scheduling dialogues. The Spanish sentence is first analyzed to produce an interlingua text, or ILT, which represents the meaning of the sentence. This ILT shows that the input was a question, that it functions to elicit a suggestion from the hearer, and the requested suggestion should be about times that are good for the hearer to meet. An English sentence is generated from the ILT. Since the parser analyzes sentences one at a time, it cannot make decisions that depend on discourse context. For this sentence, the parser cannot determine the discourse function or speech act. Depending on context, it could be a suggestion, an acceptance of a suggestion, or a statement of background information about the speaker's calendar. The discourse processor uses discourse context to narrow down the possible functions of the sentence. In the context of this dialogue, the sentence functions as a suggestion. Because the input to machine translation is a transcription of spontaneous speech, it can contain speech errors, false starts, repetitions, and other types of disfluencies. The parser accommodates this type of input by skipping parts of the sentence that do not conform to known grammar rules. In this case, it has skipped the word en, which was repeated by the speaker. This sentence is highly disfluent. The translation is not perfect, but gets the main idea across. The input to the Enthusiast system will be spontaneously spoken scheduling dialogues in Spanish. These will go through a speech recognizer, which will produce a ranked list of hypotheses about what it has heard. This is called an N-best list. The sentences hypothesized by the speech recognizer are the input to the machine translation module of Enthusiast. The main machine translation components for Enthusiast are parsing, discourse processing, and generation. Two things distinguish Enthusiast from machine translation systems for written language. First, the parser is specially designed to handle highly disfluent language. And second, the discourse processor helps us to analyze sentences correctly by placing them in the discourse context. Discourse information also helps us to translate sentences based on their function rather than their literal meaning. It is important to notice that the parser, discourse processor, and generator are all independent of the languages and topics of conversation being covered. The domain-specific and language-specific information is contained in separately coded rules. New languages and new topics of conversation are added by replacing the rules. The main processors do not need to be changed. The skipping GLR star parser is designed for input that is not likely to conform to a fixed set of grammar rules, as is the case when parsing output from a speech recognizer. The skipping GLR star parser handles disfluent sentences by skipping over parts of the input that it cannot parse, returning an analysis of the best subset of the sentence that it can parse. Because the parser has to consider many different combinations of words to skip, much of the research in developing it revolves around heuristics for reducing ambiguity while ensuring that the best analyses survive. Using the GLR star parser significantly increases the percentage of sentences that can be processed. In a recent test of English scheduling dialogues using transcribed input, the GLR star parser was able to parse about 30% more sentences than a non-skipping parser. On input from the speech recognizer, it produced about 57% more parses. For sentences that require skipping, the analysis produced by the parser is completely correct about 1/3 of the time. For another third of the sentences that require skipping, the parser's analysis contains correct but incomplete information. The analyses of the remaining third are incorrect, but the parser has internal scoring mechanisms that alert us to the fact that the analyses may be wrong. The discourse processor identifies a speech act for each sentence and also builds a discourse structure showing how sentences relate to each other. The discourse structure is called a plan tree because it represents the speaker's plans which underlie the conversation. The plans are represented at 3 levels: the general domain plans for scheduling a meeting, the speaker's problem-solving plans for determining a time and place for the meeting, and the speaker's discourse plans for making suggestions, conveying information, and so on. This is the plan tree for the first sentence of the dialogue that we saw earlier. The sentence is a surface question, which can have the function of requesting a suggestion. The second sentence is recognized as a response to the first. It is a surface statement, which functions as a suggestion. The two sentences together are recognized as part of a plan to agree on a meeting time. There are several reasons for doing this type of discourse processing. First, translation based on speech acts and discourse structure should be more accurate than translation based on literal meanings. This is because each language has its own way of expressing speech acts and discourse functions that might not translate literally into other languages. The second reason for discourse processing is that the speech recognizer can use information about the discourse context to narrow down the possible choices of words for each sentence, resulting in more accurate speech recognition. Analyzing discourse structure also enables the system to fill in the meaning of elliptical sentences and identify what pronouns refer to. This is because the possible meanings of elliptical sentences and pronouns are determined by the discourse structure. Aside from building the plan tree, another function of the discourse processor is to update the discourse memory of what has transpired at each point in the conversation. This information is also important in constraining speech recognition. As each sentence is processed, a calendar is updated showing the times that the speakers have suggested, accepted, and rejected. This is the calendar for Speaker 2 on Monday the 5th. It shows that he has suggested 8 a.m. to 9 a.m. as a meeting time. This calendar for Thursday the 8th shows that Speaker 1 has suggested any time after 11 a.m. Alex Waibel's Janus project has already had considerable success in integrating speech recognition and machine translation for English, German, and Japanese. This year's plans for Project Enthusiast focus on duplicating this success for Spanish. Integrating speech recognition with the machine translation components you have just seen will involve research on parsing without clearly identified sentence boundaries, and research on using discourse information to improve speech recognition. In addition to the techniques you have seen in this video, we are experimenting with a number of different statistical and symbolic approaches to these challenges with the goal of producing high-quality translation of spoken language.